Today's lesson is 3-5, Money Market and CD Accounts, and this is on page 109. So far in chapter 3, we've talked about savings and checking accounts, bank statements, and today we're talking about special savings accounts. So when you have your account, or when you have your money in an account like a savings account, a normal savings account, you're going to earn interest rates of like 0.5% or 0.25%. And that is because banks are using your money, therefore they have to pay interest. But they know that that money is really fluid, as in it comes into your account and out of your account very, very often. And therefore they don't have to pay high interest for it because they can't really count on your money being there from one day to the next. So they developed things that like special savings accounts or money market and CD accounts so that they could trust that your money would be in the account from one day to the next. So CD stands for Certificate of Deposit. And these are special accounts where they force you to have your money in that account for an extended period of time, and therefore they pay you a higher interest rate. So instead of 0.5%, they may pay up to 5%. And you have to have a certain amount of money in that account. So if we look at page 110, some of the rules are listed there on that page. So you have to have a minimum amount of maybe 500, 1,000, 5,000, 10,000, and you have to leave it in there for a specific amount of time. And that minimum amount of time is called a term. And then at the end of the term, it matures, or there's some kind of maturity date. And if you pull it out before the maturity date, you have to pay a penalty. So they want to trust that your money is going to be in that account for years to come so that they can loan that money out to people who are buying cars and buying houses. They can use your money and know that they will have the money available. And then at the end of 5 years or 1 year, they will have the money ready for you to withdraw along with the interest that it has earned over time. So remember when I had said that I equals PRT would be popping up over and over again? This is one of those instances. So I equals PRT is what we're going to be using to find out how much interest is earned in these accounts over time. And if you recall, I equals PRT is interest. So this is going to be interest earned in this case. Sometimes it's interest paid, but this one's interest earned. Equals principal. Okay, and this is principal deposited times rate. One thing that I think you all struggled with on the last lesson that had interest is that rate is always annual. So if they tell you the annual rate, that's what we're going to use for the R, and then time. And remember that time could be 1/12 for 1 month. It could be 0.5 for 6 months. It really just depends on the amount of time that they're telling us. But I equals PRT is going to show up over and over again, and it definitely comes into play in this lesson. So let's look at A to start with. So it says Rose deposited $10,000. Okay, so 10,000 is our deposit or our principal. Okay, in a 3-year certificate of deposit that pays simple interest, so it's not compounded, it's just simple interest at a fixed annual rate of 5.4%. So 0.054, make sure that we're moving our decimals in the right way. And it says, what total interest will Rose have if earned at the end of 3 years? So 3 years is just simply 3. Let's see how much money, or how much interest rather, she's going to earn at the end of 3 years. So she's going to earn $1,620, which is much, much higher than if it was just in a regular account. Okay, so let's look at B. Alex had a $2,000 deposit for March and April in a money market account. Interest on the account is paid monthly. In March, the account paid 3.5% annual interest, and in April, an annual interest rate of 3.75 was paid. So interest can change from one month to the next. It says, what did she earn at the end of 2 months? So it looks like she's going to have 2 different deposits, and this one is going to be compounding, I believe. Yes, this one is compounding. If your money's just sitting there and it's earning a different interest rate each month, then it's going to be compounding on itself. Yes, so for March, she deposited $2,000 and it earned an interest rate of 0.035, but that was just for 1 month. So it earned $5.83. So then she had $2,005.83. The second month, this is April, it earned 0.0375, but it was just for 1 month again. So it earned $6.27. So total, it earned $12.10, if I did my math correctly. All right, so pretty easy. The next thing we're going to look at is penalties on the CDs. So if you pull your money too early, they will penalize you with interest. So the equation is going to be exactly the same. We just need to pay attention to the wording to see exactly how much interest we're going to be charged. So let's look at C. Neil has a $2,000, so that must be our deposit, 1-year time deposit account that pays an annual interest rate of 2%. Neil cashed out the CD early, so he's going to get penalized. The bank charged Neil 3 months simple interest for the early withdrawal. So 3 months, how much will the penalty be? 2,000.02, oops, times 3 divided by 12. $10 penalty. So the equation's not any different. It's just understanding that you pay a penalty if you pull it out early. So Noelle has a 5-year, looking at D. 5-year savings or CD that pays annual interest rate of 4.7. At the end of the first year, she cashed out $12,000 CD. So $12,000 must be our deposit. And it pays an annual interest rate of 0.047. And it says that she will pay a penalty of 12 months simple interest. So 12 over 12, or simply 1. What will be her penalty? She's going to pay a penalty of $564. So quite a large penalty for pulling it out early. But sometimes you need to, right? Sometimes you need that money, so you're willing to pay the penalty. But they penalize you because their interest rates are so much higher. So the last thing we're going to do is compare savings accounts. So we're just going to be looking at one compared to the other and see which one is better. So if we look at E, it says a 6-month time deposit pays 5.35 simple interest. Dora has already calculated that she could earn $10.54 in 6 months on $1,400 deposit on a savings account earning 1.5% daily interest. How much more interest could she earn if she deposited $1,400 into a savings, $1,400 in the time deposit instead of a savings account for 6 months. So she already calculated for us. We need to try to beat $10.54. Okay, so that's option 1. So option 2 is to put it into a deposit that pays 5.35% for 6 months. So 6 over 12. So the option of the daily account, or the daily compounding amount, is that. So the other option will pay $37.45. So she should definitely do the CD account that pays 5% instead of the 1.5% daily. Okay? So the math is not any different. It's just comparing the two and making sure you're pulling out the right information. Okay, the last thing is the effective rate of interest. So there's a really good equation right there that I would write down. Okay, so the effective rate of interest equals 1 year of interest divided by the principal, or the deposit. So the effective rate of interest is the rate that you actually earn by keeping your money in deposit for 1 year. The annual rate and the effective rate can be different. The effective rate is often referred to as the annual percentage yield. So this is something that is really funny that happens. It may say that you'll earn 3%, but that's not always the case when you actually look at how much it's earning. So these tables that we used previously are not perfect. So let's look at the example, and then we're going to do H, because the one above H does not work. I have it crossed out in my book. So it says, find the effective rate of interest to the nearest 100th percent on a $1,000 deposit that pays 5% annual interest compounded quarterly. Use the compound table given in lesson 3-1. So it may say it pays 5%, but it might pay more because it's being compounded and the table is not perfect. So using the table, the effective rate is 5.1%. So it's just a little bit higher than what it said it was. So let's look at H. So it says a CD pays a 4% yearly interest and compounds daily. So we're going to be using the table in 3-1 that is blue. Find the effective rate of interest to the nearest 10th percent if $6,000 was deposited for a year. So we already know what our deposit is. It's $6,000. So now we need to find the rate of interest for 1 year, and that's going to come from our table. So let's look back at our table on page page 83. So we're going to take 6,000 times our multiplier. So we need 1 year at 4%. So we're going to take 6,000 times 1.040808. And that will give us the amount of interest earned for 1 year, which is what our top number is right here. So we're going to earn, so we get 6,244.85, but we know that not all of that is interest. Some of that was our principal, and we're looking for 1 year of interest. So we know that it's the 244.85. So if we take 244.85 and divide by 6,000, we actually get an effective rate of 4.08% instead of 4%. So we're earning just a little bit more than 4% because that table is not perfectly accurate. This is definitely the hardest concept in this lesson, is this effective rate of interest. So if you need help, please reach out, and I'd be happy to walk you through a few more example problems in the book. Okay, so this lesson is super short. There is not much practice, but that's okay. There's more practice when we go into the chapter review. So we're going to be working on page 114 number 9 through 20 all. Please let me know if you have questions.